So one of the curses of being an engineer is curiosity. So I mentioned in my previous video about the chain rollers. So I've pulled them out, and I wonder if you can guess which chain roller is which is the upper and which is the lower. It's pretty obvious looking at these two. So this is the upper one, and it does get nudged a couple of times by the chain, and this is the lower one. I'm not going to touch it because it's covered in rubbish, and you can see there how the lower chain roller is literally covered in grease from the chain and dirt, whereas the upper one's relatively clean. So I started to think, so why do we have two chain rollers? And so I'm going to show you today why I think we have. The other issue you have with these chain rollers is they're pretty simple. It's just a really simple bushing and on a bolt. And so it doesn't take much for these to gum up and seize. And so they're a little bit slack, but I can actually feel in the other one the grit is starting to get in between the roller and the sleeve, and so it's starting to bind already. So this one here, it wouldn't actually take very much for the roller to start to corrode and seize up. In fact, what I'll do, so there you are. It's not even a stainless steel roller, it's just carbon steel, and so that's the issue. So you've got a carbon steel roller, and so it'll start to corrode. So this is remember, my bike is very new, and so this roller will start to corrode. It'll then seize probably on the bolt and in the roller, and then when the chain hits it, it won't want to move. Whereas the bottom one, because it's worked constantly, it probably moves constantly, and so it'll have less chance of seizing. So what I'm going to do is I'm actually going to, because I've got the bike on the stand, on the motocross stand, and the shock off, I can actually move the wheel up, and I can show you why the top roller is very rarely touched. So what I've done is I've put about 3 inches of travel on the rear swinging arm, and that approximates your sag when you've just got your race sag, so your rider plus your bike. So 3 inches, and the chain is not too bad. It feels a little bit tight, but anyway, you can see there how the chain, I've just put this on loose, the chain still is very close to the bottom roller, and that's why it looks like it's used quite a lot, and that's why your chain tension is important. If you've got too much chain tension, you're going to be on that bottom roller constantly. You can see there you're miles off the top roller still. I don't know if I can get better in there. You can see how you're miles off that top roller, and so that top roller's not used at all. And so really, even if I pull it up, it's not even close to that top roller. So top roller is not going to be used, but we've still got some movement to make. So that's normal sag. As you know, a bike has about 9.25 inches or 235 mil of total movement. So what I'm going to do is I'm going to jack this up a little bit more, and that'll give me the 235 mil, and we'll see that. So that's the wheel jacked up to its maximum travel, or close as, so the wheel's pretty high there. Chain becomes extremely slack because it comes off your, basically comes off your arc, and then your chain is at its maximum slackness. So you can see what happens here is, under tension, at your maximum suspension load, your top roller will get, can you see that? Your top roller will get top. So if you're under your maximum suspension travel with your chain slack, your top roller will get hit. Your bottom roller, however, is miles off, so as the wheel moves up, it moves off your bottom roller and catches your top. But where it really causes a problem is if you come off the power on high suspension travel, your chain will go slack at the top and it'll go tight at the bottom as the wheel pulls it through, because you come off the power of the engine, and then your chain will go slack here and it'll want to whip about. So it'll hit your chain guide on your swinging arm, which is what it's designed to do. But then if it comes up, it'll want to whip up and hit your roller. So that's why your roller has to stay free. But if your roller wasn't there, that chain whip would travel forward and then either hit your frame or your casing on the way through. And so that's why I think this roller's in place, is to stop that chain whip on the way through when you're in compression, when you're in rear wheel compression or shock compression, and the top of the chain goes slack when you power off. And so that's why I think you need this top roller, is to stop that chain whip going forward. So the key is to keep that top roller free. And so what I'm going to do is I'm going to get some ball bearing rollers for this. So I'll get a ball bearing roller for the top of the bottom and the bottom, and then we'll make sure that the chain is always adjusted right. Because obviously if you've got too much chain slack, that's going to really whip across when you power off under suspension load, and that's when you get the chain whipping up probably and hitting this roller. And so as I said, under normal load conditions, both rollers are relatively free, but at the ends of the suspension, and if you have your chain adjusted wrong, that's when you start to have problems, I believe. So keep your rollers clean and free, keep your chain well adjusted, and you shouldn't have a problem. And as I said, I'm going to replace my rollers with ball bearing ones because I think that's a poor design. So I thought these Japanese engineers would have a reason for this top roller. So when people say take it out, I'm not sure it's a good idea, because your chain whip just goes forward rather than stops here. So in my opinion, I would have a good roller on the top, and as I said, I'd make it a ball bearing one, and make sure it's always free, and keep your chain well adjusted so that you don't get that chain whip at either ends of your suspension travel. And as I said, I think that's why the rollers are there. The bottom one is when your suspension's low and it stops your chain sagging down too much and hitting your frame. And your top one is to stop the chain whipping and hitting your engine and your frame as well. And so as I said, these Japanese engineers, they're smart, they've designed bikes for a long time, they'll have a reason why this is there. And so as far as I'm concerned, I'm going to make sure I've got two good rollers and my chain well adjusted. And actually I've just thought of something else, that's why your rear shock sag is important. Because if you're not getting that 3 inches rear shock sag for your rider sag when you initially sit in it, your chain is far too far up. And so that's why it's important to have the right spring weight so you get good sag for your weight and the bike weight. Too much sag and your chain's going to be too high all the time. And so that's why make sure your sag's right, make sure your rollers are right, and make sure your chain's adjusted properly. And then you should never have a problem. So in summary, here's a picture of a diagram of the front sprocket, the rear sprocket, and the swinging arm as it moves up and down, and the two rollers, top roller and bottom roller. So as this thing moves up and down within its normal loaded suspension conditions, it doesn't seem to engage the rollers very much. The chain slack, if it's properly adjusted, in tension it will run under this roller, and it'll be slacked in the bottom, or in compression it seems to run over it without touching it. And so under normal conditions it seems to just run either between these two rollers. So the top roller comes into play when the suspension's at maximum travel, i.e. if you did a big jump or bump. I don't actually think it has much, it touches it much. I think it's probably under it all the time. It will engage if your suspension's compressed and you take the power off, because your chain will be slack on top and it'll want to lash forward. So it may also engage if the chain is too slack under power off conditions. It's definitely engaged less than the lower roller. It didn't have much wear on mine after 1,000 Ks. And it seems to protect the frame and the engine casing. The bottom roller, however, I think it comes into play a lot more, because basically if you brake, it throws the bike forward. The swinging arm relatively goes down, so it goes slack under here, and you could see the state of those rollers. The bottom was much dirtier than the top. So I think the bottom roller comes into play more. It'll also come into play if the chain's too slack, because it'll run off here and then it'll travel across the roller and then down again. So I think it's engaged more than the upper roller, and that's anecdotally from the state of them. And I think also it protects the frame and engine casing under here if it was too slack. And so basically, in normal conditions, in summary, it runs between the rollers. The upper roller protects the frame and casing under a chain lash condition, and the bottom roller protects the frame and casing under a chain slack condition. And so that's probably why these two rollers exist. So they seem to be designed, as I said, I might have said earlier, for end case boundary conditions to protect the bike. So I recommend you get the right spring rate so the bike sags properly and the chain's not too close to either roller. The chain tension has to be correct, or the chain adjustment has to be correct, so the chain is not inclined to hang too low or lash forward. Ensure your rollers are clean and lubricated and rotate freely, and if you can, replace the rollers with seal ball bearing types for minimum maintenance. And if you do that, you shouldn't have any problems with your rollers, and the bike will be incident free. So I hope that's helped you. As I said, I wouldn't recommend taking the top roller off. I think it's got a use, and the Japanese engineers, they designed it for that use. And so, as I said, make sure your rollers are good condition, and I'm going to replace mine with ball bearing types. Thanks for watching. Hope this helps somebody.